check out that definite integral. That definite integral looks kind of complicated. Let's use u substitution. Most of the time, you would probably want to look at that and say, oh, let's let the denominator be u. Okay, if you're going to let the denominator be u, then the denominator, all of it, square root and everything would be u, and then you're going to run into some complicatedness. Let's not let the entire denominator be u. Let's let u be 2x plus 1. Okay? So then we'll go from there. So I have the derivative of u, which would be 2 dx. And I don't want 2 dx, I want 17 dx. Well, I'll put 17 dx. But then the question is, how do we turn a 2 into a 17? And the answer is not, let's add 15. The answer has to do with multiplication and division. So I would multiply by 17. Now I have 34. That'd be too much. Then I'd divide by 2. So I'd have 17 halves. So I'd divide by 2 and multiply by 17. There we go. So let's rewrite our definite integral. We are going to do this one by hand. And we're going to have the square root of u in the denominator. So I'm not going to underline things, color coordinating, all that. You can if you want to, but there is u. And then 17 dx is the only stuff that's left that we haven't written, and that would be 17 halves du. I'm going to put it in the front, like front, and we'll do that. So proceeding with this idea, sometimes these are hard to integrate without doing a rewrite, so let's do the rewrite. So we're going to have 17 halves integral of u to the negative 1/2 du. And now we'll integrate this. We're going to add 1 to that exponent. So that gives me, ooh, I'm leaving some stuff out. We'll come back and pick it up in a minute. I just got so excited about integrating that I didn't do the rest of it. I forgot about those numbers, which is really the whole point of the lesson. So, oh well, let's just keep moving. So u to the 1/2, 17 halves, you could say 1, but 17 halves divided by 1/2. You could say 1 divided by 1/2 would give me 2, and that works. And then you'd have 17 halves here, and that's just going to give you 17 in just a minute. Now, I originally said 17 halves divided by 1/2. It's another way of looking at it. 17 halves. You could grab your coefficient from here or here, either way, but don't forget what's in front if you grab your coefficient from here. Old coefficient divided by new exponent, 17 halves divided by 1/2 is 17. We just got that just a second ago. And that is going to be on the interval from, okay, haven't done that part yet. Let's do it. Because we are using u substitution, that's what it's called. U substitution on a definite integral, we need to plug these numbers in here, and we're going to do that right now. So we're going to plug a 4 in right here, and we're going to have 2 times 4 plus 1. That's going to give me 9, and 9, and 9, which is going to be really convenient because we're going to have to square root that number, and it works out that way. And then we're going to plug a 12 in here, so 2 times 12 plus 1 is 25, 25, 25, there we go. So we now have 17 times the square root of 25, 17 times the square root of 25 minus 17 times the square root of 9. And instead of us complicating our lives by being like, well, what's 17 times 5 and 17 times 3, which isn't too complicated, I think we could do this instead. Let's just factor the 17 out, take some square roots on the same step, and we're going to have 17 times 2, which is, wow, my brain just shut down for half a second there, 34. 34. I said we would do this without a calculator, but let's confirm our answer. Just a good quick review of how to do this on a calculator. We will press, can you see it? Yeah, math, 9. We're going to go from 4 to 12 of 17 over the square root of 2x plus 1 with respect to x, 34. Okay, check this out though. Check it out. It's kind of cool. Math 9. Let's do this one instead. You'll get the same answer. It's so neat. Well, let's actually start over with 17 halves and then go from 9 to 25 of 1 over the square root of u. We'll just call it 1 over the square root of, oh, let's use the right variables. Let's use u with respect to u. And this should give us 34. Are you as amazed as I am? Yeah, hope so. Okay, we got the answer to this one. Let's do the next one in the same video. So I'm going to spend a minute erasing. Not an entire minute. That would just be a waste of time. I can make small talk while I do this, but I'm not. Okay, next one looks a little ridiculous. It's a lot of fun. So here we go. We're going to go from 0 to 1 of x cubed plus 2x, and then times the square root of x to the 4th plus 4x squared plus 4, and then dx. Okay, again, complicatedness staring us in the face. My right eye itches, and let's get started. I see that there are two things multiplied together. Later we're going to have a different strategy for integrating something in BC Calc that would be kind of like undoing the product rule in a sense. However, I want you to see this. I want to point this out. The derivative of this is this if you divide by the right thing. So 4x cubed, oh, let's divide by 4. 8x, oh, we could divide by 4. So we have what we need here. The derivative of this shows up here. We need to tweak it with multiplying or dividing by something, but it'll work. So let's do it. The inner function is maybe not super obvious, but generally it's the stuff inside a square root. That often happens, not always. So u equals x to the 4th plus 4x squared plus 4. And the derivative of that is 4x cubed plus 8x and dx. And that's amazing and wonderful and fantastic, but I don't want that. I want 1x cubed plus 2x. Well, then I better divide everything by 4. So x cubed plus 2x dx, 1/4 du, and I'm writing with a very squeaky marker. Okay, so what we have is going to look like a lot of stuff just really got simplified, which is the point, right? So the integral from somewhere to somewhere, we'll cross that bridge in a minute, of the square root of u du, we'll put a 1/4. Put the 1/4 in the front if you want to. Well, things got very simple, very fast. Like all this got shrunk down because u was such a long polynomial. And so then when you substituted it out, it went away. And also, again, x cubed plus 2x dx, x cubed plus 2x dx is 1/4 du. Everything's accounted for. It's easy to look at that and say, you're leaving stuff out. Nope, it's all there, except the fact that I haven't plugged in 0, and you get a 4. And I didn't plug in 1, which gives me 9. Conveniently, those are both square rootable. It was engineered that way. Okay, nah, let's not. I was about to do a step in my head, and I find it best not to. Again, this 1/4 can go in the front or in there, either way. This is u to the 1/2 and then du. We're going to add 1 to the 1/2. It's going to give me 3 halves. And I will do old coefficient divided by new exponent. And that would be 1/4 times 2/3, which would be 1/6. 1/6. From 4 to 9. All right. Before I go any further, I want to make sure I'm right. I'm going to pause here, stare at it awkwardly for a second. Feel free to stare with me. Are you staring? Should be. I think we're good. All right. Let's plug in a 9. 1/6 square root of 9, and then we'll cube it, minus square root of 4. And then we'll cube that, and I'll just go ahead and factor the 1/6 out of that whole process. So that's going to give me 3 cubed, which is 27, and 2 cubed, which is 8, and I have a 1/6 of that, and that's going to give me 19. 19 over 6. Done.